Okay, here we've got a question on Newton's second law. It's a grade 11 question from November 2018, question 5. It says a crate with a mass of 25 kilograms slides down a plane which is inclined at 15 degrees to the horizontal. During the first part of the motion from A to B, there's no friction, but part BC has a rough surface. Okay, so we've got two different situations going on here. It says, draw a free body diagram of all the forces acting on the crate while it moves from B to C. Now, B to C is this part here where there is friction, okay? So the crate is shown at the top of the slope, but we are actually going to look as it's on the friction part of the slope. So the first thing we do when we draw a free body diagram is we make our nice little circle, okay? Remember, the arrows must point out of the circle always. So the first force that is acting, this crate has particles in it, so it has a weight, or Fg if you prefer. Okay, and then I'm going to draw in the slope very lightly here, okay, and then rub it out later. I'm drawing in the slope nicely here so that I can draw in my normal at 90 degrees. And remember, you can use your set square to do this. And then finally, what is the third force? Remember, there's 3 marks, so I must have 3 forces. The third force here, which is acting parallel to the slope and opposing motion, remember the crate is going down the slope, is my friction. Okay, so now I've just rubbed out my slope, but now you can see that my friction is going up the slope and it's at 90 degrees to my normal force, and my weight is going down the slope. Remember, all your forces must have arrows, all your forces must have labels, and they must all touch this dot that you've drawn, otherwise you will not get your 3 marks. Now it says, calculate the magnitude of the acceleration of the crate while it moves from A to B. Now we just drew the diagram from B to C, and it had 3 forces, but if we're doing the calculation for A to B, we actually have to draw another force diagram. So this one was B to C. If we are going A to B, okay, it is a different situation. I never changed the color. Let me just quickly change the color here. If we are going A to B, we still have the weight of the crate and we still have the normal force, but we don't have friction anymore. So we've in actual fact got only 2 forces acting here. And they are not in a straight line, so they are of no use to us at this point. So we have to resolve them into my Fg perpendicular component and my Fg parallel component. Okay, and now I've got my normal force and Fg perpendicular in a line and Fg parallel going down the slope. So I can get rid of my actual Fg force, the whole force, and just leave its 2 components. So now once I have my force diagram, I can calculate the acceleration of the crate while it moves from A to B. So I'm going to go down, the slope is positive because you don't ever do a vector calculation without stating which is your direction of positive motion. Then I can write my formula, F net equals ma. We're trying to calculate A. The m was 25, so that side of the equation's got 25a. What is my net force? The net force parallel to the slope is just Fg parallel. And we know Fg parallel is a fraction of Fg. Fg is the weight, so the weight is the mass, 25, times the acceleration due to gravity, 9.8. And the parallel component will be the sine of the angle, which is 15 degrees. So you get this equation here, and then you end up with 63,41 equals 25a if you use your calculator, which means A is 2,54 meters per second. Remember, this is to the minus 2. Can you see if I write this carefully here? No, it doesn't want to write. Let's rub this out then and make sure that we write it with the unit, because no unit, no mark. Okay, 2,54 meters per second to the minus 2. And this is going down the slope. okay? The acceleration is down the slope, but the question just asked for the magnitude, so they're okay with a number without the direction. Okay. Now it says to you, write down the direction of the acceleration of the crate while it slows down. So now the crate is still moving down the slope like this, okay? So if the crate is moving down the slope and it is slowing down, something has to be opposing the motion, which as we know is friction, okay? So then therefore the acceleration has to be up the slope, okay? Because the box is slowing down. If the acceleration is helping the velocity, they've got the same vector direction. If the acceleration is decreasing the velocity velocity and the acceleration have two different directions. So the acceleration has to be up the slope. Now they've put this here to help you with the next part of the question, okay, to make you think about what is happening here. It says the magnitude of the net acceleration from B to C is 1,2 meters per second. Calculate the magnitude of the frictional force acting on the crate. So let's go back to our original force diagram, because we can't do anything without a force diagram, okay? If we look at this B to C force diagram, this is the situation where we are calculating the friction, because here's this force that we want to calculate. So the first thing we have to do is we have to make our forces in a straight line. So down the slope I'm going to have FG parallel, and perpendicular to the slope I'm going to have FG perpendicular, okay? So at this moment we are only interested in these two forces which are parallel to the slope. So if we carry on with our calculation, remember we said down the slope is positive, okay? So we're going to use Newton's second law, so we write the formula F net equals ma. So now remember, to find F net you add your forces together, okay? So down the slope is positive, so Fg parallel is going down the slope, and we are going to add the force of kinetic friction, but it is going in the opposite direction, okay? So we've got Fg parallel minus Fk equals ma. But now remember, this acceleration is a vector, and they reminded you of this in 5.3, and we said this acceleration is going up the slope, but we've just said down the slope is positive. So when we substitute here, okay, if we substitute for Fg parallel, remember we worked out Fg parallel over here is 25, the mass, times the acceleration due to gravity times the sine of the angle, and we get 63,41. So 63,41 minus the force of kinetic friction, okay, which is what we're trying to find, equals the mass, 25, times the acceleration. Now they said to you the magnitude of it is 1.2. But you must realize acceleration is a vector, and we are going to substitute negative 1.2 into here. So we get 63,41 minus the force of kinetic friction is going to be equal to, what is this? This is negative 30. So the force of kinetic friction is going to be 63,41 plus 30, which is going to be 93,41 newtons. So the hardest thing to remember in this question is the acceleration is going up the slope. The acceleration is a vector. It is opposing motion. So that is why we have to put it in the equation as a negative number.